conclude over there. Then we got into the pneumatic actuator, wherein the working medium is actually the air. So instead fluid need to be striked out. That I have not corrected that, I'm sorry. The relationship between force and the area is the same as that of hydraulic system. Force equal to pressure per unit area. So when you want to raise the force, what you need to play, the item what you need to play with, it is actually against the same pressure, play with area. If you reduce the area, automatically force is going to be increased. If you raise the area, automatically force is going to be decreased. This is how the consideration is. Anyway, the difference between oil and the air. Oil actually, when you apply some pressure onto a fluid, rather onto an oil, its volume is not going to be compressed. We will not find change in its volume. Whereas the force, whatever you are going to add on that volume, is going to contribute towards the rise in pressure without finding or observing major change in its volume. That is not the case in the case of air. Air, say for example, the rooms wherever you are occupying, the air has occupied that entire room space. If you want, you can extract that and you can compress. To what extent? To the extent you want it to. So to the extent you have compressed, based on that the pressure is going to be. That is the reason why when you observe the air compressors being situated outside, they trap the air, extract the air from the ambient, and in the compressor they extend to reach, they compress in the compressor, and from there they are going to deliver it into the tank, air tank. So more and more is going to be the air that is going to be accumulated into that, compressed and sent to that. Based on that, the pressure of the air that is available in the tank is going to go on rising. You all have experienced this because in our thermal engineering laboratory, you have got two-stage air compressor. Over there, there is one air tank. In the beginning, when you switch on the air compressor, in the beginning, pressure is going to be the extent at which it was. For a particular time span of time, when you keep it on running, it goes on increasing. The pressure goes on rising. Okay, so the reason is the moment the compressor has been switched on, the air is being compressed to some extent, and that is going to be supplied to this air tank. The moment it has been supplied to the air tank, it has got scope to expand, and again pressure drops. So more and more is the air you are going to supply in a compressed mode, then the volume of air whatever you are going to supply to the air tank, it is going to occupy its pressure available in the tank, and more and more you supply, its pressure is going to go on rising bit by bit. Okay, so this is maybe from that particular tank only you will be in a position to use the air for your purpose. Okay, so this is how the requirement is actually changing. Maybe that is the basic reason why the pneumatic devices are less efficient than the hydraulic devices. Then coming to the pneumatic actuators or the devices used for converting pressure energy that is available with the compressed air to the mechanical energy to perform useful work. See, in the case of pneumatic hydraulic actuator, there the energy flow was from mechanical energy to the pressure energy, and then pressure energy to the mechanical energy. Even here on the same grounds, because you are trying to run the compressor to raise the pressure of the air, means it is trying to take the support of electrical energy, then within the motor mechanical energy, then that is trying to contribute towards the rise in pressure of that particular air, then it is going to be converted to the mechanical work again. So you should also have an idea on the flow of energies, from what form to what form it is actually getting converted, finally to what form it is getting transmitted. That also you should keep it in mind. Actuators are used to perform the task of exerting the required force at the end of the stroke, or used to create displacement by the movement of the piston. So this is a common statement That holds good either for the pneumatic activator, even for the hydraulic activator. So what it is trying to do, it cannot create force in the beginning itself. It need not even. Say for example, it has to hold this cell phone, say. We'll hold this with certain pressure. Beyond that, if you try to hold it, it may, those end effectors may pierce into that. Okay. So depending upon the component you are trying to handle, the pressure is actually varying. Okay, that too, there is no need for the end effectors to apply the same pressure on the component prior to the before that has got close to this. Soon after that has got close to that, maybe at the instance of holding that, only that at that instance the force need to be. Right from the beginning it applies. Then throughout its travel, that force is going to be applied on the object, whatever it is trying to apply, handle. That is going to definitely spoil the object, whatever it is trying to handle. So this is one of the major reason why it has been stated that actuators need to apply the exert the pressure or the force only at the end of the stroke, or okay, in order to at the time of moving the piston. Okay, that is how the statement has been categorized on those grounds. The pressurized air from the compressor is supplied to the reservoir, that we have discussed already. From the reservoir, the pressurized air is supplied to the pneumatic activator to do work. How to maintain the pressure within that particular reservoir? It is obviously you are going to keep the motor on, compressor on. That condition what we have straight away maintained in the case of expand, air compressor expand, we have already done. We put on the compressor and we ensure that the pressure is rising to a particular level. Soon after that has raised, we try to release the valve so that we ensure that pressure is not rising beyond that. Okay, so at that time we try to measure the energy, or we try to measure the displacement. All those things we try to do at that level. Same is the case even over here. Okay, now let us see some more aspects pertaining to this. These are used for high speed as well as for high load carrying capacities. And this drive is clean and fast but difficult to control. The difficulty is due to the compressibility of the fluid. Okay, so controlling is not going to be that easy. That's what they try to tell. Because valve, as we have faced the difficulty in order to maintain the pressure of the air in the tank, we have went on adjusting the valve. For some instance, that valve might cope up to deliver more and more air. Because of that, the pressure might drop. Once again, you have to regulate that valve. So that is how it is going to face certain difficulties. And of course, the drive is clean, not exactly, rather, it is not, you cannot compare this with the hydraulic. In the case of hydraulic, whenever leakages happens, hydraulic oil comes out of the device. Whereas here, even if there are certain leakages, it is being fluid being air even if it comes out, it will not disturb the environment. It will not spoil the environment, working environment. That is how this drive is actually being stated as clean. For both electrical and hydraulic drive robots, majorly pneumatic tools are used as tools are used as end effectors. So you may have a robo that might be trying to use electric drives or hydraulic drives. But when it comes to the extent of end effectors, there majority of the robots are going to use only pneumatic tools. Okay, so that is what is the importance of this particular statement. The pneumatic drives are recommended to use for handling simple operations like to pick up light objects, simple objects. Okay, when it comes to the types of pneumatic activators, pneumatic cylinders can be used to get linear, rotary, and oscillatory motions. There are three types of pneumatic activators. They are as follows. First one is linear activator or pneumatic cylinders. Second one is rotary activator or air motors. Third one is limited angle activators. Okay, so these are the three different types of pneumatic activators which are coming under this particular category. Pneumatic cylinders are the devices used for converting the air pressure into linear motion or force. See, I have tried to move my arm. Altogether, this wrist has moved. If an object has been kept here, in that instance, if I move, though I am providing linear motion with certain velocity, when an obstruction has been put in between, that is going to apply, that linear motion is going to apply force. That is how this particular statement is. It has been used to convert air pressure to get linear motion. In turn, we are trying to get the force. The pneumatic cylinders are mainly used for simple applications, say clamping, stamping, transferring, branching, allocating, ejecting, metering, tilting, bending, turning. Turning is a process when you try to refer. Rod diameter has to be reduced, or step turning, offset, all that you need to. Okay, some what do you call eccentric turning, all such sorts of applications are going to come. When it comes to clamping, when it comes to clamping, it comes when you want to hold certain objects between jaws. Simple, in a simplest sense, when you want me to give a clarity, in a drilling machine, we try to use certain jaws to hold certain objects. Even in lathe, even in simple, what do you call, fitting operation, rather fitting process, or in carpentry process, when you try to consider fitting wise, in that you are trying to fit something, they are the jaws, you are trying to clamp. So when you try to rotate a particular shaft, then a particular jaw moves and an object being kept in between, that is going to be clamped. Sometimes what happens, there will be thread being given on both the directions. Because of that, for a simple turning, both the jaws will be made to move and gets clamped. Stamping, there will be one what do you call shaft that will be moving up and down. Whichever the object goes between under that, on that it is going to put a stamp and goes on uh, completing its process. Okay, so likewise, all these are the simple process what we can visualize and understand that these are all being referred under simple applications. And of course, if you want me to broadly classify these pneumatic activators, that has been categorized into four groups. One is based on the application for which air cylinders have been put in use. Second one is based on the cylinder action. Third one is based on the cylinder's movement. Then based on the cylinder's design. We may not see all these things, but I thought of giving you this particular content, keeping in mind that sometimes it may be asked for you for higher marks. We are not sure. You should have some content as reference to be discussed, to be referred, or to be represented on paper. Sometimes if you get admitted into a, if you get a job in this particular area, you should not go mad when you look at all these things. So then I thought nothing wrong in giving this particular input. Light duty, medium duty, and heavy duty. based on the application for which that cylinder has been put in use. It is with respect to the extent of the loads or the criteria of targets whatever you are trying to handle, not being clearly what do you call, I have not uh, got the crystal clear classification between these three. But altogether, for simple, very simple applications, you can consider that as light duty. A better, heavier jobs, reasonably heavier jobs, can be considered under medium duty. Much more heavy duty tasks can be considered under this particular heavy duty. That way, you can imagine. Then, based on the cylinder action, when you try to consider single acting, double acting, and under double acting, you will get single rod type double acting, and under the same B category, you have you have 1 second, 1 second. I'm sorry. Okay, 10 minutes. So under single acting, double acting, and under double acting, you have got single rod being attached to the shaft as a shaft. Double rod in the sense two shafts are going to be attached to that particular shaft. That is how the things are. So in single acting case, what happens is one side of the shaft, one side of the piston only being put into action. Something like that side only the air fluid is rather the pressurized air is going to be admitted. On the other side, we will not have any what do you call, air is not going to be admitted onto the other side of the piston. Maybe you can categorize those sides as left side and right side. Pressurized air is going to be either admitted onto the left side or admitted onto the right side. Such a sort of situation, if it is happening, such a thing is being referred under single acting. Coming to the double acting, pressurized air is going to be admitted either into the left side or into the right side of the fluid. Okay, so in that particular process, okay, for a double acting piston, if you have one rod being attached on one side, means you can imagine one connecting rod that is moving forward and backward, something like this. Say this is the piston, say this is your shaft, and this is the rod according to this. If this particular rod is single, then when the piston moves forward and backward, that means this particular rod will be moving only one side of the piston, only on the right side of the piston. That case is actually coming under C, single rod type double acting cylinder. Then, if you have a piston like this, my hand, you assume that as a piston, and you have got shaft attached to this side as well as this side. Now, this is rod 1, this is rod 2. When the piston is moving, both the rods are actually moving. That is actually coming under category D, double rod type double acting cylinder. Then, based on the cylinder's movement, rotating type air cylinder, non-rotating type air cylinder. Okay, so they are going to introduce vane in that. That vane is going to be introduced into that. So vane, when you have, that can go on rotating within the cylinder, and it is something like rotary vane, wherein when the vane rotates, the air being trapped in between, the space is going to be, volume is going to be reduced, and because of volume is getting reduced, its pressure is going to go on rising. That way you can imagine. That is how rotating type and non-rotating types are coming into picture. Telescopic, like camera. What happens when you have a zoom camera? In between one shaft there is going to be another shaft, and in that again there is another shaft. Because of that you can bring it out. And rodless tandem type, you will see such a kind of arrangement in IC engines. In rodless, there will be no rod at all. Piston only will be there. No rod at all. That piston moment will be there because of the support of magnetic that you can see here, magnetically coupled slide, and of course cable cylinder. We will not see all these varieties, maybe few out of them we will see in the next portions of the slides. But what you need to do is, out of your interest, if you want, you can dig out and you can go through them. And if you have got really interesting aspects, you can ask me, I'll give you permission. In this particular slot, you will be permitted to present your what do you call, your collected information for a span of 5 or 10 minutes. That's quite possible. And of course, cylinders with sensors, so many varieties are there.